Good morning, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and we are now in the home straight in this specific series of videos about the November 2021 Paper 1 exam. Remember, ladies and gentlemen, that we have now already done 9 questions. If you haven't watched the previous 9 questions, I encourage you, give it what you've got. Go and watch those videos. Make sure you understand the basics behind how to answer these questions. Now, today's video specifically, ladies and gentlemen, is looking at calculus, but the applications to graphs, specifically cubic graphs. So hang in and look at this, work through this yourself, and try it before you actually watch the rest of this video. Answer this question to the best of your abilities, and then I will assist you in what is my thinking that goes on in answering these questions. So now that you've tried it yourself, or at least I hope you've tried it yourself, I want you to basically stop the running into this question that most of my matriculants do. Most of my matriculants, when they run this, they kind of just run into this, they rush through the information, and they don't really think about what is happening or why it is happening. So when we look at a sum like this, I'm going to start by analyzing every little bit of the information that I can get before I actually answer this question. I like to call it mining, like you're digging into a mine. So when we look at something like this, the graph of h of x is equal to ax cubed plus bx squared is drawn. So first of all, look at the graph. What do you see? Well, it is a cubic graph. That's very important because it has then certain possibilities or certain properties that actually work with specific cubic graphs. In this case, because the graph is ending down, it means that a value must be smaller than 0. One thing that I didn't even think about until I'm recording the video now is what is the y-intercept? Well, it's 0, and I can also see that because there is no plus something at the back, plus some constant. So there's a 0 there. But I also see that from the graph. It goes through 0 there. Now, next up, it says there's turning points. So what must I remember from turning points? Well, the derivative is equal to 0. But where are the turning points? At 0, x equal to 0, and x equal to 4. So that is very important, those two things. So automatically, I have 2 equations that I could work with. H accent of 0 equal 0, and H accent of 4 equal 0. But also, a very important thing is, they tell me that B lies on the graph. Therefore, if I substitute x with 4 and y with 32, I actually get another equation. I get another set of equations that I could work with. Lastly, it tells me A is the x-intercept, so y is equal to 0. At this moment of time, I've basically analyzed all that I can from this sketch. There is one more little thing that I could analyze, but I'm going to leave it for a bit later on. Now that I have my information, I'm going to look at the first question. The first question says, show that A is equal to -1 and B is equal to 6. Remember that that comes from that equation. Please don't confuse small case a with capital letter A. Okay, please don't confuse those two with each other. It is very important that you don't confuse them. So when we look at this specific sum, they are actually asking me to determine the equation. Ladies and gents, I just want to kind of ask you for the following. If you go to the examiner and tell them h of x is equal to negative x cubed plus 6x squared, and now you, for instance, substitute points in, and you derive and put points in, and you solve and you solve and you solve, you will get 0. You are not allowed to start with what they say you've got to find to answer the sum. You're not allowed to at all. So you must ignore what they tell you to get it equal to. You actually have to say, okay, I don't know what A and B is. Let me just solve. I see students every year trying to start at the end point where they want to. And now they say, okay, but what if? That but what if gives you 0, ladies and gents, so don't do that. You are not allowed to start where what you want to prove. Okay, please, 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 please don't do that. Okay. So I'm going to determine the equation of h of x. So what I like to think about is there are 2 variables. Therefore, I need 2 sets of equations. And I'm going to solve them simultaneously. Now, looking at the information that was given, the first bit was that h of 4 is 32. And the second bit I'm going to look at is also at x equal to 4. Because it's not just a point on the graph, it is a special point. It's a stationary point. And this means I can have 2 sets of equations. First of all, if I substitute x with 4, I've got to get an answer of 32. At this point, ladies and gents, I'm just going to simplify and see where it goes. So 64a plus 16b is equal to 32. I'm not going to waste more time at this moment to try and get variables, etc., etc., etc. I just want to move over to the other one and let's see where that leads me. Okay. Don't just rush, don't just run. I want you to constantly be thinking. I want you to be strategizing. When we look at this, I've got h accent of x, which is the derivative. 3ax squared plus 2bx, because I'm deriving in terms of x. This, ladies and gents, is now actually the derivative everywhere. But where do I want the derivative? Specifically at 4. So I'm going to substitute 4 in and put it equal to 0, because it's a derivative. This leads me towards the second equation of 48a plus 8b equal to 0. You have this and this equation to solve simultaneously. I'm going to go and get b alone in the second equation. So b is equal to negative 6a. Substituting that into the other equation, so I'm taking this and I am substituting it into there, I am getting 64a minus 96a, which is 32. So negative 32a is equal to 32. So dividing by 32 on both sides leaves me with a equal to negative 1. I like it because it is right. It's what they told me in 10.1 to prove. But also, ladies and gents, remember what we said right from the beginning. A must be negative because it is ending down. Looking at this, I can now solve b by substituting a into b, and b is equal to 6. I know my sum is right and I love it. But please, ladies and gents, if you couldn't do this, then from 10.2 onwards, you are allowed to actually use that formula that they asked you to prove for A and B. As simple and as easy as that. When we look at now 10.2, when we look at 10.2, it says here, calculate the coordinates of A. Remember that you have h of x equal to that. Whether you could prove it or not is irrelevant, but you've got h of x equal to negative x cubed plus 6x squared. What is A? What makes A special? A is the x-intercept. If A is the x-intercept, then y must be 0. Going to h of x and making y 0, I'm going to simply take out the negative x squared common, and I'm left with x minus 6. So this leads me towards negative x squared equals 0, or x equal to 6. The first one can only be true if x is 0, and then x is equal to 6. Which one is it? Let's quickly look at our graph. Okay, let's look at our graph. They're asking you for A. Is it 0 or 6? It's definitely equal to 6. Please remember, ladies and gents, that they're asking you for a set of coordinates. If they're asking you for a set of coordinates, you have to write it as coordinates. They are allowed to deduct 1 mark. If your teacher wants to in the prelim exam, they can deduct 1 mark. So please answer the question. Let's look at the next one, question 10.3. Write down the values of x for which h is increasing. Now, when I think about increasing, I can go and do it algebraically. But why would I want to do that if I've got the graph? Increasing, remember, means your graph is going up as we go left to right. If I analyze my sketch, from left to right, it starts going down, goes up, goes down again. Now, where does it change direction? At x equal to 0 and at x equal to 4. Those are my 2 places where it changes from sloping down to sloping up and then sloping down again. So where is the only place, in which domain is my graph sloping up? Well, only there, and that is between 0 and 4. Why do I use round brackets? Remember, at x equal to 0, so there. My graph is neither positive nor negative. It is flat. So I am going to not include it because there the derivative is equal to 0. Same at 4. My graph is flat. So therefore, I am not going to include those. That's why I use round brackets. Let's look at 10.3.2. At 10.3.2, they're asking me about concavity. What is concavity again? Remember, concavity is whether the graph is either frowning or it's smiling, okay? And when I look at this graph, where is my graph concave down? By looking at the graph, concave down means frowning, so my smile is upside down. And that is from somewhere between 0 and 4 all the way to infinity. By analyzing the sketch, and this is a very interesting little bit, that in cubic functions, your point of inflection, this point where it changes from concave up to concave down, remember we call this the point of inflection, okay? When we look at the point of inflection, it's always going to be exactly in the middle of my two turning points or my two stationary points. So if my one stationary point is at 0 and my other stationary point is at 4, the point of inflection is, boom, in the middle, 2, x equal to 2, which means my answer is x greater than 2. But what if I don't want to do it graphically? What if I want to do it algebraically? What if I don't like this whole interpreting the graph? Well, you can, of course, ladies and gentlemen, use calculus. For concave down, remember, it's where the second order derivative is smaller than naught. Now, I made a small mistake by going f double accent, where it should actually be h double accent of x, because that is my graph. So but please use the right one. Use h because they give you h. Don't use f like I did here. So going f accent x, oh again, I use f instead of h because I'm so used to f that I use the wrong one there. Deriving it for second order derivative, why do I keep on writing f? Man, h. Remember to use the right notation. We don't have an f sketch. I can't use f double accent x. And oh my goodness, do I use f again? Oh man, h double accent of x smaller than naught. Putting that expression smaller than naught, now I have to solve for x. Remember, if I divide both sides by a negative, what must happen to the inequality sign? It has to swap around. So my answer is x greater than 2. But wait, that's exactly what I got there. Oh my goodness! Whichever one works for you is the one I encourage you to use. Remember, those of you that are wanting to get 80s, 90s, and 95s and above, okay? Those of you aiming for the hundreds, make sure you can get both methods correct, because you don't know in your prelims or finals how the examiner is going to ask this of you. Okay, that is a very, very, very important thing to remember. Let's go and have a look at 10.4. Now 10.4 was an absolute beauty. What I did first of all is I kind of analyzed this equation and I removed that first part of it simply because it kind of reminds me of h of x, okay? So when I look at this and I aptly again made this f instead of h. Oh, before the end of this video, I hope I'm going to get it right. I might still get it wrong a few times, but please forgive me today. When I look at h of x, which is that, how do these two expressions relate to one another? That is an important thing. Well, if I look at replacing x with x minus 1 and keeping that as being h of x minus 1, remember it means that I replace every x with x minus 1. So every x I must replace with x minus 1. But that is exactly the expression I got out of the question. Now, what does this mean? It means a move or a shift or a translation is the actual correct mathematical terminology. A translation of 1 unit to the right. So if we look at this, I don't want you to try and do this in your head. Okay, I want you to look at it on the graph. So if I look at the graph and I take every coordinate and move it 1 unit to the right, okay, 1 unit to the right, and I take every set of coordinates and I move it to the right, I've got those 3 sets of coordinates there. 1, 5, 32, and 7, 0. Where did I get that? Literally just moving. I hope you understand that. Okay, let me just erase these ones, otherwise they're going to confuse my sketch later. How would the graph then look? Well, there I've got the sketch of h of x plus 1. Okay, the sketch of h of x plus 1. When I look at this, the graph that I've sketched, h of x minus 1, if I said x plus 1, oh, my apologies. Sometimes with these negatives and positives, you know, it just messes me up sometimes. But I promise I'll get it right for the rest of the video. If I look at the graph of y equal to h of x minus 1 minus k, that k is a move up or down. Now you might come and say, wait, where do you get this from? Remember, this first one, the first part of my expression, is h of x minus 1. Okay? So what I'm looking at now is what is the effect that this minus k has on the graph, this red graph that I drew. Well, it's a shift or a translation or a movement of the graph up or down. So the question is actually, for which values of k will I take that red graph, move it up or down, so that I have 1 negative and 2 distinct, which means different, okay, positive roots. But that root actually means where y is equal to 0. So in other words, x-intercepts. Okay, that's actually what they're asking me for. So if I take that red graph that I drew, the movement of 1 unit right, and I start moving it up or down, how will I have to move it so that I've got 1 negative x-intercept and 2 different positive x-intercepts? So the first option that I've got is moving it up. But if I move it up, I'm only going to have, look, that big purple x, 1 positive x-intercept. I don't want that. Or I could move it down so that I've got my y-intercept to be at 0, 0. Then I have 1 x-intercept that is 0, and I've got 2 x-intercepts that are positive. I don't want that because I want 1 negative. The next option I've got is drawing it down a little bit further than the x intercept, okay, or my y-intercept being 0. And that I like, because that means I've got one negative x-intercept and two distinct positive x-intercepts. Two different x-intercepts. Now there are many options more than that. I could move it down more. Okay, I could move it down so that I have, okay, just give me a moment. I just want to go back one. I could draw it down so that your turning point is either on the x-axis or below the x-axis, but that would not satisfy this restriction that I've got, because the restriction says I've got to have one negative and two distinct, meaning different positive roots. But this one only has one x-intercept on the negative side, and if it turns on the x-axis, it has one positive distinct root, or two equal positive roots, which I don't want. Or even if I move it down further, it would have no x-intercepts. So let's erase the ones I don't want. I want only that one there in the middle. Okay? In other words, ladies and gents, I need to, okay, I need to look at that. What am I doing there? Just quickly get this, what I'm doing there. And again, I made it F. Oh my goodness, I will eventually get it right, ladies and gents. I just needed that x-intercept there, so that I know how many units or more I've got to move it down. By doing that, ladies and gents, I know that I can see my answer as being my graph must be moved down more than 7 units, but less than 32. By moving it more than 7 units, then I'm going to have my y-intercept there, which I like because it gives me those 3 specific x-intercepts. But I don't want to move it down more than 32 units, because then my turning point is going to be below the x-axis, which I don't want. So how do I finalize now my question? My final question now says, let me just rewrite this for you. I'm going a little bit too fast. That negative k, remember, is your movement down. Okay, let me go back a little bit. So that negative k being smaller than negative 7, that means I've got to have a downward movement that's smaller than negative 7. In other words, negative 8, negative 9, negative 10, which I want, because I want it to be moved down more than 7 units. So I want to have it moved down 8, 9, or 10 units. But I don't want it moved down more than 30 or negative 32 units. So in other words, like this one, it gives me up to negative 31.99999. I want negative 30 or negative 31 units, which means I now have to solve for k. So if I solve for k, I'm going to divide the left-hand side by negative 1, but then my inequality swaps around. So k must be greater than 7, although that 7 does look like a greater than sign. So 7 units. Okay? Doing the same on the right-hand side, the right inequality, swapping my inequality sign, k must be smaller than 32. I just love, ladies and gentlemen, to write this down as being a final single equation if it is possible. Because now it says k must be greater than 7 but less than 32. Remember what this means, and I just want to write this in for you. I have now h of x minus 1 minus some kind of value. And what we are saying is that that value must be, for instance, 8 or 9 or 10. So that means a movement down, for instance, of 10 units, which would mean my graph, if I look at this, would go here through -3, and my turning point would be at 5, 22. If I subtract 10 from every one of those points. So this is another way you could analyze it. But ladies and gents, I encourage you to find this method that works for you. If you are still struggling with the sum, if you are really not getting it, I encourage you, maybe go and see your teacher. Or come and, send us a message, or maybe find me somewhere on LinkedIn or so, and just send me a message and say, sir, would you mind explaining this to me again? But I encourage you, sit with your mates, or sit with your teacher, sit with someone else in your class and talk about this. Discuss it. Don't just go to a teacher and say, sir or ma'am, I understand nothing. Please explain it to me. That's not the right way of doing mathematics. The right way of doing mathematics is sitting with a problem, discussing possible solutions, sitting with, 2, 3, 4 mates, talk it out. If you four can't solve it, bring in maybe an older person, whether it be a teacher, maybe a mom or dad that's an engineer. Draw sketches, discuss things, spend time on a sum. But if you are a 30, 40 or a 50%er, and this sum that I did, this 10.4, just completely goes over your head, and you have no clue, go on to the next question. Try it, but go on to the next question. In an exam, ladies and gents, you don't want to get stuck on a question like this for like 10, 15, 20 minutes, because it's only a 3-mark question. So please don't get stuck on this question for too long in an exam. When you do homework, that's a different story. But in an exam, just try it, skip over to the next question. If you've got time, you come back and you attempt to do it again. But the important thing is to be wise with your time. This is a long video, but man, I enjoyed it. I hope you enjoyed it as well. So keep well and tune into our next video, which is going to be about optimization. Question 11 of the exam of 2021 from the Department of Basic Education. So this is Mr. VG signing out. Enjoy this time with me. I'm enjoying it and loving it. And thank you for paying attention. Have an amazing rest of your day. Keep well. Cheers.